Okay. So today we're going to move on in our review. Everything that we're doing for these first 5 days, folks, is basically a review to get you ready for algebra. We haven't actually started yet. We have been doing algebra. We've been doing pre-algebra, but these are some basic concepts that you guys need to know in order to be successful in this unit. So we've got today, we've got tomorrow, and then we really get started with our Singapore math curriculum. Okay, so order of operations. This should be review for you guys. Who remembers what the acronym PEMDAS stands for? Who remembers what the acronym PEMDAS stands for when we're talking about math problems? And I need eyes on me and everyone with their knees under their desks showing star. That means you're scooted all the way forward and you're not scooted back from your desk so that you can easily turn around and talk to or look at your neighbor. Okay. Oh, and go for it. Okay, so yes, you got everything except the E in a little bit of a different order, but that's okay. We'll go over the order in just a second. So nice job. Okay, what does the E stand for? Mira? Not equations. Morgan? Exponents. Great job. All right. Oh, please excuse my dear Aunt Sally. Okay, so let's go ahead and write down what these stands for. You should be able to do this on, I actually don't have a slide. I'm going to have you copy this on the bottom of that first page. So go ahead and write it exactly as it appears on the slide, because that's part of memorizing a process. All right. So parentheses, exponents, multiplication and division, addition and subtraction. We're writing this on the bottom of your first page. It's really important that you might write multiplication and division next to each other, just like that, and addition and subtraction. And when you get done writing, I'll explain why. Okay, again, it's really important. I want you guys to write it exactly like you see it there. So multiplication, division, right next to it. Addition, subtraction, right next to it. Don't list them from top to bottom. Write them down like you see them on the slide. And I'll explain that in a sec. Okay, so when we solve problems in math, we have to have an agreed upon order of operations, and this is it. So in any problem where we've got multiple operations, we're going to start, if there are parentheses, we're going to start with the parentheses. A lot of times there aren't. Next, we would do exponents. Then we would do multiplication and division. But why do you guys think they're on the same line here? Any guesses? Morgan?
Because they both come right after, like, so after
Yeah. Yeah, exactly. Multiplication and division are weighted the same in order of operations. And so we're like, when they're in the same problem, we're going to choose whichever multiplication or division problem is on the left, right? So we work from left to right in the problem. Same with addition and subtraction. Next, we would do addition or subtraction, but we would start on the left and we would move to the right, just like you read. Can anybody want to guess why? I mean, where did this order of operations even come from? Like, why do we do parentheses first? Why do we do exponents next? Why do we do multiplication? Then why do we do addition and subtraction last? What do you think, Uzziah?
like, you can't subtract like 16 from 20.
Oh, I can.
Or 20 from 16.
I can. You will later this year. Yeah. We will later this year. But that's a good guess. That's okay. Cameron?
Like change the value of the equation.
Well, it does. Yeah. I mean, if we don't have an agreed upon order of operations, you guys can come up with different answers, right? Okay. So I don't know that you guys are going to guess this, but when we talk about multiplication is repeated what? Addition, right? And then division, subtraction is just the inverse of addition. We're going to talk later this year about how subtraction's actually really just addition with like positives and negatives, but we're not there yet. And then division, of course, is just the inverse of multiplication, right? Do you guys know what I mean when I say inverse? What does inverse mean? Kylie? Opposite. It means the opposite. And then exponents are repeated what? Does anybody remember? Rajveer? Yeah, they're repeated multiplication. So when we look at the order of operations, it makes sense. Parentheses are just, those are a symbol to tell us to do something first. We have to solve what's in parentheses first. But then from there and to the bottom of the list, you know, we have to do exponents first because it's repeated multiplication. We have to do multiplication before we can do addition because it's repeated addition. And then last on the list is addition. Does that make sense to everybody? Let's keep going. Okay, so let's do, is this my first problem? Yes. All right, so we're gonna write an expression for the volume of the side of a cube. I apologize for the typo. If the cube measures S centimeters, it's kind of hard. We're just like starting right off with a variable and not even a number. So a cube, what does a cube mean? What is a cube? Mendel? Has three measurements. Good. It has 3 dimensions, doesn't it? So if I'm looking at a cube, and you guys are writing everything down that you see me write. If I'm looking at a cube, Mendel was right, it has 3 measurements. And it says, if the side of the cube measured S centimeters, then I'm going to go ahead and put an S right here. What's unique about a cube in terms of how the measurements of the sides relate to one another, Piper?
They're all the same.
Yeah, they're all the same. So that's going to be S, that's going to be S, and that's going to be S. All right, does anybody remember how to find volume? Whoa. Yeah, Kylie? Yeah, that's part of it. So volume would equal, but we don't have, let's see, that gives us 2 out of the 3 dimensions, right? Length times width, but we've got another dimension there. Michael? Times height, yeah. Do you guys recognize something right here? What's that? It's area. And so we could say that volume equals area times height. Okay, so if we want to write an expression for the volume of the side of a cube, whose side equals S, let's substitute S in for all of those measurements, all right? So it's going to be S, and let's use the dot here instead of the times. I don't know why my dots keep disappearing. S times S times S. Is there a way to simplify that? Dorothy? Yes, yes. So the way that we say that, we don't say S3, but I know exactly what you're trying to tell me. S to the 3rd power. That means S times S times S. And then of course we need to add our unit because this told us that it was centimeters. What is the volume unit? What is the volume unit? Yeah. Yeah, good job. Nice math word. Centimeters cubed. So we don't normally we wouldn't write S times S times S. That's kind of cumbersome, isn't it? And I know how 6th graders are all about writing the shortest thing possible. So because 6th graders will literally take 30 seconds to walk to my desk and ask me, should I write S times S times S, or can I like shorten this? So we want to simplify that, and we want to write what we just wrote right here, S to the 3rd. And that is called an exponent. So for the last line of your work there, it says where you see the superscript right here, this is called an exponent. Add exponent. Morgan?
On the bottom of the cube.
Yep. That is an S centimeters, yeah. Let me erase that so you guys can see. Okay, make sense? You guys ready to move on? Not quite. Changing the slide in 4. All right. Oops, it's not. Here we go. All right, we've got a box with a square base and it is 4 centimeters on the side. What is the area of the base? We just reviewed our area formula just a second ago. You remember that? Area equals what, class?
L times W.
Length times width. Length times width. Good. That stands for length times width. So now it's telling it, this is also a substitution problem, isn't it? What am I going to substitute in for the length and the width there for this box with a square base that we want to find the area of the base for? It says you have a box with a square base, 4 centimeters on the side. Sorry about the random line. Okay. What do I substitute in for length and width? Cecilia? What's the length? Take a look at my diagram. Good. What's the width? Yeah. So for my next line of work, I'm going to say area equals 4 times 4. Okay, so we can solve this one, and I'm going to relate this back to exponents in 2 slides. But what is the area of this particular square base? Class, what's 4 times 4? 16 what? Okay, all right. So did you see how we just squared 4 right there? We did 4 times 4. We could have also written that as 4 squared. All right, let's keep going. Now let's write an equation for the volume of the box if its height is 5 centimeter. Okay, so remember we had a box. Let's draw it again. We're going to draw a cube this time. It's not a cube. It's a cuboid. Sorry. Yeah, because one measurement is different. Okay, so we had 4 and we had 4. And now we've got the third dimension is going to be 5. Let me draw that a little bit more. All right, just a minute ago, I told you volume was what? What's the formula? Piper? Yep, length times width times height. And we could also say volume equals area times height. And the reason I'm telling you guys that now is because when we get into our volume unit, we're going to be finding the volume of cylinders. We're going to find the volume of all kinds of things. And so if you can remember area times height, then that's going to really help you out quite a bit. Okay, so what's my substitution line on this one? McKinley. Yeah, 4 times 4 times 5. Great. Could those be in any order? Yes. Okay. So let's solve that. 4 times 4 is, okay, 16 times 5. Okay, who's got that? Oh, I heard it. Who said it? Nice. What is it, class? Nice job. 80 what? Centimeters cubed. Way to go. Good job, guys. Okay. Do we all have that? Let's relate this back to exponents now. So in the next slide, let's write an expression for the area of the base of a box is B centimeters. Okay, let's start with our formula. Area equals, say it, guys. Good. What do I substitute in for the length and the width this time? Lucy Cole? Yes, my area is going to equal B times B. Is that simplified? What is my simplified answer going to look like? Tommy, do you know? How can I shorthand B times B? Owen? B to the second power. Yep, great job. So that's what our answer would look like. B squared centimeters squared. Declan?
On your floor model picture.
Uh-huh.
How do you know that the box is a square?
Well,
It could be a rectangle.
let's see.
And how?
Yeah, in this particular word problem, it wasn't as specific as it should have been. I'm assuming it is a square just because it says the base of a box. It did leave that information out on my PowerPoint. So yeah, that's a good question because it should have said if the base of the box is a square. Yeah. Okay, now we're gonna write an equation for the volume of the box if its height is 5 centimeters. What was the area of the base of the box, you guys, again? Just building on the very last problem. What was the area just a second ago? Ashen Grand Prix? B squared centimeters squared. So remember we had this thing and it was B times B, but now the height is going to be 5. So the first line of work, we're writing a formula. Again, volume is length times width times height. And then we are going to, I'm sorry, I'm thinking about something really quick. Then we're going to fill in our substitution line. Okay, so what's my next line of work? Tommy. Yeah. I know, so here's the deal. It doesn't matter. So the height, when we say height, it's like the third dimension. So the height is whatever connects the two bases. So like, if you can imagine, there's another base back here, right? And the bases of a prism are opposite each other. And so whatever measurement connects them is the height. So that might be down here. It might be going this direction. It doesn't matter though, because it's multiplication. Okay, so we're gonna do B times 5. Now, how can we simplify this? You guys already know that B times B is B squared. What's the best way to simplify this? Macy? No, it's not 5 to the third power because this is B. This is not 5. So what do we do? Jace, go ahead. Yes. Now there's a certain way we have to write that though. So B to the second times 5. Remember, we've got to write our coefficients first. Kylie, what would be the actual way I would write it? Not quite. There's an easier way to do it. But good guess. Mira?
5b to the second power centimeters squared.
Yes. 5b squared. Remember our coefficient. This is the number that is being multiplied times the variable. Our coefficient always goes first. 5b squared centimeters cubed. Oh my goodness. Okay. Let's go ahead and do a couple problems together from your notes from that last sheet. Okay, I think I want to focus on exponents. And we're going to add a little bit more of the order of operations tomorrow, I think. Because we're a little bit behind today. So, all right, so let's look at the top of your sheets. Okay, so when you see the word expand, all that means is you're going to take what's there and you're going to write it out. So for example, 6 to the third power, how many times am I multiplying 6 times itself if it's to the third power? Kylie? Yeah, so you're going to write 6 times 6 times 6. If it says expand, that's all you have to do. You just have to write that down. That's pretty easy, isn't it? So don't get confused, you guys, with this. This does not equal 3 times 6. What's 3 times 6? Class?
18.
What's 6 times 6? What's 36 times 6? 216? 200, I think I can't, yeah. I have the cubes memorized when we get to that unit, but in between I have to refresh my memory and I didn't. So very different numbers, aren't they? 6 times 6 times 6 is way different than 3 times 6. All right, number 2, solve 6 to the first power. What would that be? Piper? It would be 6. Great job. Okay. Expand 6 to the 5th power. Go ahead and write that down. Okay, what did you get? Shafiq?
6 times 6
Okay, great job. Should look like this. And we're using the dot, you guys, instead of the multiplication symbol. All right, write 7 times 7 times 7 times 7 as an exponent. What does it look like? How many 7s do we have there? Isaiah?
7 to the 4th.
7 to the 4th power. Great job. You guys must have spent some time on exponents, I feel like, last year.
Yeah, that's a little bit.
Well, I feel like you're pretty solid on these so far. So, okay, number 5, write as an exponent, n times n. Well, how do I write that? Ashland Grand Prix? N to the 2nd power, good. I can't tell if some of you are not raising your hands because I'm going too fast or because you've already got it. So if you know it, everybody raise your hand because I'm using that as a gauge to like see where you guys are at. Does anybody need me to slow down? You guys are good? Okay. All right, let's do that one. Number 6 is a repeat, isn't it?
Yeah.
Let's skip that. Oh, so is 7. All right, let's go to 8. Oh, I changed it on my PowerPoint, but that's okay. We're gonna skip ahead. Okay. Expand, substitute, and solve if a to the 3rd power, if a equals 2. First of all, how do I expand that? You guys just did it. Cameron? Good. So your first line of work should look like that. What do I substitute in now for a? Rajveer? No, it says a to the 3rd power if a equals 2. 2. So it should look like this. 2 times 2 times 2. What's my answer? Owen. 8. Nice job. Okay, Declan, do you have a question?
No.
Okay, you had the answer. All right, do number 9. Expand, substitute, and solve. Okay. Who's got it? Okay, McKinley, tell me what to do. Like that. Good. Great job. 81. What, you know what, an easy way to solve these kinds of problems too is like since you can multiply in any order, you can do like half the problem like that. 9 times 9, and then you can solve the final problem, which would be 81. Great job. Okay, I think that you guys have it. So we will order of ops a little bit more tomorrow. For tonight, I want you guys to do this. This is called exponent. So while I'm passing this out, you could be putting away your notes into your binder and writing this into your planner. For your planner, write down exponents. Just a second, buddy. Where's my, oh, there it is, my keyboard. I need that.